All right, I think they have been pretty thoroughly heated up. All right, we'll let that cool down, and we will move on to trying to crush them into a fine powder. Well, hello, Scrappers. Mike here. Welcome back to my channel. And I don't know if you folks remember, but back a few months back, actually, it was like last spring, I got a visit from a fellow in Finland named Jani. And he brought me samples of the stuff he's been scrapping and collecting. And Johnny is a scrapper extraordinaire. He has just thousands of pounds of scrap that he has accumulated. I did a sample of some pins that he gave me, some gold pins. He has 40 kilos of those type pins accumulated, and another 40 kilos of another type pins. By now, it's probably 500 of each, the way he goes. I've seen stacks of circuit boards that go from floor to ceiling, and just bins full of stuff. So Johnny's a scrapper extraordinaire. He visits the U.S., he vacations over here every year, and he brought me some stuff. We'd talked in advance. He brought me the pins, he brought me some other stuff, and he asked me to do some testing for him to see what kind of yield I could get out of him. And it's pretty good with the pins, and we're still kind of possibly debating whether or not I can do the bulk of his pins for him. I think it's mostly down to whether I have the time for it, because I'm very busy these days. Something else he brought me, which up till now I haven't had a chance to deal with, are some little MLCCs. He brought me a collection of MLCCs. Now, there's not very many here, but Johnny just brought me some stuff he could get in his carry-on luggage. He has a lot of these. And he wants to know if there's any precious metals in them. Is he wasting his time collecting them? And, well, I'm kind of thinking that these are modern magnetic ones. Let's get a magnet and try. Let's see how magnetic they are. Oh, goodness gracious, yes. So, these are pretty magnetic. And you know the mantra, it's only the non-magnetic MLCCs that have precious metals in them. Well, let me see here. Yeah, no, it looks like they're pretty much all magnetic. So, but Johnny would like me to test them anyway, just to see if there is any precious metals, any silver, any palladium, anything else of any value in them. It's a pretty small sample, but I think I can figure out a way to test them and see. So I think the first step towards dealing with these is, I think, incineration. Get rid of any plastic casing. They're mostly ceramic and metal, but there might be some plastic there too. So I'm thinking we need to incinerate these. So I'm going to put them in a little dish here, and we'll hit them with a torch and incinerate them good. And then we'll move on from there. All right, so I was thinking I should probably weigh this stuff before I do anything else, just in case there are some PMs in it. Maybe we can calculate some kind of yield. Pretty windy this morning. All right. I'll blow my weigh boat away before I can get this weight done. So we got about 5.41-ish or 5.40. I think the wind is really screwing me up here. We'll go with 5.4 grams of material and put this back over here. So let me get the torch out and we will incinerate this stuff and then contemplate ways to crush it into as fine a powder as I can before further treatment. All right, going to hit this stuff with my MAP gas torch. And see what, if any, effect that has. So far, not a whole lot. So clearly there's not a lot of volatile organic matter in there. I can see the solder melting on the contacts where they still have solder on them. Turn the heat up a little bit. I'm also hoping that this process will make these things a little more brittle so they'll be easier to crush. They're glowing red hot. Yeah, but there's really not much else happening. So these things are basically ceramic and metal. Clearly. Nothing else there. Ceramic and metal. But I think I'm going to keep this heating up for a little bit, just in the hopes that this extreme heating breaks down the ceramic a little bit and makes them easier to crush. I've got a couple of ideas on how to crush them. You know, if I had more of these, I'd use one of my big ore crushers, but there's just such a small sample that I think I'll just lose most of it in the crusher. But I do have a couple of other ideas. So hopefully this process will make them a little bit easier to crush. I guess we'll see. All right. I think they have been pretty thoroughly heated up. All right. We'll let that cool down, and we will move on to trying to crush them into a fine powder. All right, the first thing I'm going to try is an old school mortar and pestle and see how I do with this. If this doesn't work, we'll move on to something else. So this crucible's still a little warm, so that got it all. Okay. So let's see how this works. Not very well, I have to say. This stuff is pretty darn hard. Okay. Okay, we're going to move on to something else, because as far as I can tell, I haven't done anything except flip a few of the smaller ones out. There's one right there. There's another one. And there's one right there. All right, so we're going to try something else. Hopefully, will work a little bit better. Well, I don't seem to be getting anywhere with the mortar and pestle. These MLCCs are just too hard to crush with this thing. I don't think there's enough material here to use my Mighty Mill or my Smash-O-Matic ore crushers. They're made for, you know, larger amounts of material than this. So what am I going to do? I think I'm going to have to go medieval on this stuff. I really do. So I got my old manual ore crusher out. I think this might do it. I really think this might do it. So I've cleaned this out pretty good. I don't think there's any residual ore in there. We'll probably be adding a little bit of rust to it, but there's already iron in here. We know that. So in it goes. All right. And we shall proceed to try and crush this stuff with this thing. All right, I got some hearing protection on because I know from experience this is super loud, so here we go. Oh yeah, that is doing the job. just got some powder down in there now. Let me crush it up some more to make sure, because some of those MLCCs were really, really small. So I want to make sure that everything gets smashed up in there before we move on. So I'm going to do this a little while longer and just make sure everything's a nice fine powder in there. And then I'll dump it out into this beaker and we'll move on from there. Okay, I think I've smashed this stuff sufficiently. Let's see about recovering the powder. And since we don't have a very big sample here, try and get all of it I can into this beaker. Get some more of it out of here. Yeah, there we go. Wants to stick to the bottom and the sides, but the paintbrush is getting it. It's a small sample, so if there's any PMs in here, it's going to be hard to figure out if we don't get all of it. All right, so there's Johnny's crushed MLCCs. Not a lot. I think I'm going to transfer this to a much smaller beaker, and then we can start processing it to see if there's any PMs actually in here. There we go. I've transferred it to my smallest beaker, and it's still it's still a very small sample for this beaker. But I was tempted to use test tubes, but I think I'll go with the beaker and see what we can do with this. So let me get this in the fume hood, and we will start giving this acid treatments and see if we can get any precious metals out of it. All right, so let's run a test on this stuff. It's weird to have such a small little beaker in the fume hood, but that's all we got for a sample right there. So I'm going to add some distilled water to it. Right about there, I'm thinking. And then I'm going to add some of my homemade nitric acid to it. I'll put a link in the upper right to the video where I made this nitric acid. I'm going to put a fair amount in. Well, no, I'm not, because I'm afraid it might bubble over. There might be a vigorous reaction. So I'm going to put maybe 1 milliliter in to start with. I'll add more later as needed. And unlike in the video where I did the tantalum capacitors, which I'll put a link to in the upper right as well, I'm not too worried about wasting nitric acid dissolving the base metals in here, because there's just not enough material here to worry about. So let me get this warming up a little bit on the hot plate, and we'll start digesting the metals in there. Now, we know there's iron in there. There might be nickel. There might be other stuff. There's definitely some tin from the solder, maybe some lead. But the metals we're interested in, if there are any PGM, if there are any precious metals in there, they would be silver and palladium. Well, those will both dissolve in nitric acid too. So my plan here is to just keep adding nitric acid to this stuff until all the metals are in solution and there's no more reaction. And then we'll check it with stannous chloride to see if we have any palladium, and we'll check it by putting a little bit of it into some water with some hydrochloric acid to see if there's any silver. So we'll do those two tests on it. But first we got to get everything into solution, so we'll just let this sit here and cook and see if we get any kind of reaction out of it with 1 milliliter of nitric acid. I got a feeling I'll probably be adding more. Well, let's let it warm up and see what happens. Alright, it's been a few more minutes, and we're definitely starting to get a little bit of brown orange fuming in there. It's probably not showing up on the camera. I can barely see it with my eye. But it's there. It's there. The bubbling is still going on, but it's slowed down a lot. So what I think I'm going to do is I'm going to wait until this reaction basically dies down entirely. Maybe give it another shot of nitric. And that should be, I think, plenty. With the size of the sample that I had, if I put another milliliter of nitric acid in there, I would think that would be enough to get all the metals in a sample that size into solution. And we'll just let it cook until there's definitely no more reaction. Then we'll give it a test and see what we got. Hey, look at that. You see what I see? The liquid's turning blue. So we're getting copper or nickel in this solution. I'm going to turn this down too because it looks like it's really starting to boil in there. And I don't want it to boil over. But that's great. That's great. We're getting the base metals into solution. That's exactly what I wanted to happen. So I'm going to let this go until it doesn't look like there's any more reaction going on, until it cools down so it's not boiling so hard. And I will give it another shot of nitric acid. I don't want to put any in right now because I think I could prompt a boil over. So, in fact, I think I'm going to take the watch glass off. Yeah, because it's starting to get a little foamy in there. Turn your back on it for a minute. Anything can happen. So, I'm going to let it cook now, for now, cool down. And if it looks like the reaction's done, I'll give it some more nitric acid. And then we'll just let it simmer on low for a while and hopefully get all the base metals in solution. Then we can do the tests we need to do for silver and palladium. Okay. Be back when something interesting happens. Alrighty, this has cooled down a little bit. Doesn't look like it's in any danger of boiling over. I'm going to put a little bit more nitric acid in it. Slowly, just in case. There's maybe another milliliter. So I think we got a little over 3 milliliters of nitric acid in there. Considering the size of the sample, I suspect that is enough to get all of the base metals into solution. So we'll just let this sit here and simmer on low heat. And then I'll probably shut it off and let it cool down. And hopefully the liquid will clarify over time, and then we can do our tests on nice clear liquid. That's what I'm hoping. We'll see if it does. Alrighty, so this has had time to settle and cool. Got a nice clear liquid on top. I'm certain I've put enough nitric acid in here to get everything in solution that will go in solution. Got a sort of a blue-green color. I'm thinking we got nickel, which is what they use instead of palladium and silver in the cheaper, more modern MLCCs, where they're not using the precious metals. So from the color, it's already not looking good. But let's be systematic about this here and make certain, okay? So since it's nice and clear, we can do a few tests here without too much trouble. We'll do a spot plate test here with some stannous chloride and see if we have any trace of palladium in here. Let me move the camera so you can see maybe a little better going on with the spot plate. Right. Some very fresh stannous chloride solution that I just made. And well, it's bleaching the color out. It's we're not getting the characteristic green color of palladium there. The blue-green color's kind of faded out, kind of turning yellow in the center. I don't think there's any palladium there, unfortunately. So I think that's a negative for palladium. So let's test for silver now. I've got another little beaker here. Some tap water and a little splash of muriatic acid in it. if there's any silver in this stuff, we should see a white cloud form when I put this in. So let's see what happens. Uh-oh. No white cloud. All we did was dilute the blue-green a little bit. It's still clear. Well, Johnny, there you go. Sorry to say, yeah, your MLCCs don't seem to have any precious metals in them. No palladium, no silver. So, yeah, you were asking if you were wasting your time saving them. And I would say, yeah, if they're magnetic, you're wasting your time saving them. Sort them out with a magnet. Save the ones that are non-magnetic. But, yeah, the ones that stick to the magnet really well, just give them the old heave-ho. You don't have to keep saving those. So anyway, there's your answer. Sorry it couldn't be, you know, more positive, but it's better to know than not know. Everybody else out there, thanks for watching this video. I appreciate it. Subscribe to see my future videos. And I'll see you in the next one. Thanks a lot for watching this one. Bye.